Our next speaker is Gary Spittle, founder and CEO of Sonical. Gary's presentation topic, Ear Computers, the Foundation of Headphone 3.0. Gary will describe how Sonical is building the platform for Headphone 3.0 that unlocks the secret weapon of your ears, an untapped resource of biometric data.
Okay, if we think about the ear and we think about the products that people wear, the first thing that comes to mind is about listening to audio. So we're all familiar with AirPods and earbuds and headphones, and we understand that we use these things for listening to music and maybe making phone calls. But there's so much more that we could do beyond just listening to sound. We can improve the way that we hear sound. We can improve the bandwidth and the quality of sound and let the user control how they hear different types of sounds. But none of these things are really possible with today's platforms. The next area that's really interesting is about listening to the world. How do we hear the sound around us, and how can we enhance that? Not just for people that need hearing assistance because they have some kind of hearing loss, but for everybody. We could all benefit for some kind of hearing assistance, just like we have reading glasses. Why don't we have something similar for our ears to give us that power assist when we're in a noisy environment, such as a restaurant or a coffee shop, and we're having a conversation? Why can't we have some indication of what's going on around us when we're outside and we're listening to music or we're making a phone call? Why can't we have more intelligent control about noise? So today we have noise-canceling headphones, but they don't just cancel noise, they cancel everything. But if we had some intelligence there, maybe using a bit of AI, we can actually select as a user the sounds that we do want to hear and those that we don't. All of these things can be possible if we had a new computing platform. But the real secret about the ear is this third one. It's about listening to your body. Now, it turns out the ear is one of the best locations on the body for gathering biometric data. It's far more stable than the wrist. And yet today, there's hundreds of companies building apps specifically for smartwatches to gather metrics at the wrist. And they all know that it's not the best location, but that's where the chip is. So of course they're going to write apps for the wrist because there's no alternative. As soon as you put a computer in the ear, now we have a really interesting situation. So we can pick up all your vital signs inside your ear. We can measure your blood oxygen level. We can measure your temperature, your motion. It's a much better place for picking up voice biometrics. So we can measure your level of stress and anxiety and fatigue. It's a fantastic place for measuring brain activity. You can't do that on the wrist. So the ear is this untapped resource of information, and we intend to unlock it. So right now, the market is pretty much divided into two categories. Apple have completely dominated the ear-worn devices with the AirPod, and everyone else in the Android space has been left behind. And so before we even formed Sonical, while I was doing consulting work with Audicus, we spoke to hundreds of product companies, and we tried to understand, well, what is it that's holding you back? Surely, you've seen what Apple are doing. How do you catch up or even beat Apple in this market? And it was very interesting, the information that we got back from these people. And using that data, we now know what the killer app is for the ear. And it'll be a surprise to most people to realize that it's the same killer app as the laptop. It's the same killer app as the phone. It's the same killer app as the smartwatch, which means it's whatever the user wants. These companies that build products can no longer predict what every one of their consumers needs. They have to let the consumer decide. And that's the beauty of having an operating system that gives them access to applications, rather than baking everything in when they try to build a product. So that's exactly where we started. We built an operating system. We provided this to lots of different technology companies who said, now that you have this, you can get access to new technology really fast. And developers love it. Right now, if you're a developer of some software, let's say you're building an AI system, you have to customize your code and all of your engine for each individual chip. You have to have intimate knowledge of the pipelining, the instruction set, how the memory architecture is configured. But with an operating system, all of that goes away. Now, of course, it's not as efficient, but the computing is really accelerating to make this possible. So what is Headphone 3? Well, to define that, you have to start with Headphone 1. So Headphone 1, some of you may remember back in the 1980s, Sony had this device called a Walkman. It actually used cassettes to play music. And people used to walk around listening to music outside, and headphones became popular. We then quickly moved to Headphone 2 in the early 2000s. And this started with a company in the UK called Cambridge Silicon Radio, who really caused this Bluetooth transition to happen. And my role within CSR was to enable this. How do we get companies to throw away a cable and replace it with all this expensive technology? And we managed to do that. We showed them all the benefits and we supported that transition. Now where we're at, though, is Bluetooth has imposed a whole bunch of limitations. And this means that some of the manufacturers can no longer bring the technology they need into their products. Bluetooth is effectively in the way. But at the same time, there's a lot of pressure from low-cost products coming into this market that effectively can build the same device. So why would I spend $300 on a Bose headphone when effectively I can get the same thing for $50 in Best Buy? So there's a lot of pressure in this market, and the companies are looking to escape. And while this is happening, Apple decided they're going to do things their own way. So they built their own processor, they have their own RF, their own software stack, and they can do whatever they like. And that's why they dominate the market. They're not waiting for the existing chip companies to improve Bluetooth. They're doing it their way. So it's inevitable that this transition to Headphone 3 is going to happen. We need to have a way to bring apps into these products much, much faster. We were doing consulting projects for some of the biggest headphone companies in the world, and just to add one small feature could take months or even a year. We simply have to move quicker. We can't rely on that method anymore. So the ear computer is completely user-driven. It will have intelligence way beyond today's basic Bluetooth products. So why hasn't this already happened? It seems so obvious. And the answer is the silicon. The silicon's the foundation of all of this innovation. And so what you find today is if you look at the chips that we use in our phones and our laptops or even in the cloud, they've been on this amazing performance trajectory and they just keep getting better, which means we can do more and more with these products. If you also take a look at things like the Sony PlayStation, the silicon inside that has improved a phenomenal amount since the very first version of the product. But for the ear, we've barely moved anywhere. And again, because Bluetooth says, well, all I need to do is play a bit of music and make a phone call. I don't need anything else. But we know that that's just not true. And where we have to be is a lot further away. We need a completely new system. The other part of this is connectivity. If you look at how our phones connect into various networks and the amount of data that can come in and out of these devices, it's simply astonishing. But we need that data pipe for the apps that we're running so that we can watch video on our phones now that simply wasn't possible 20 years ago. But again, Bluetooth's in the way of the ear. We've barely changed the data pipe, so it's no wonder we're not doing anything special. So we have to change the data pipe too. So why would this transition actually happen? Well, it's actually inevitable. If you look at how other products have moved in the market, especially things like the mobile phone, they used to be defined by the product company that was building it. So companies like Motorola and Nokia, they would define exactly what our phones did. But it soon became too much for them. It took too long to add new features. And we know what happened. We moved to a smart device. Now the user decides what happens on that product. It's no longer a burden for the product company to decide it. They simply pick the capabilities and they differentiate their product range based on that performance. They don't differentiate on the features that are available. The same thing is going to happen with our ears. They have to be personalized. It has to be an open platform. These are devices that we literally stick inside our body, so we should be able to have some control over what it does. And today, we basically have none. So the architecture is actually very similar. If you think about the architecture of a laptop or a phone, it's really concentrated around one major processor with some co-processors and other accelerators with an operating system sitting on the top. And again, the developers love this because now they can build an app that works everywhere. They don't have to build custom code for all the different chips inside everybody's laptop. They build it once for Windows and they know it's going to work. Same thing happens on the phone. We can build an app for Android and we know it's going to work everywhere. We don't have to know what chips are inside everybody's phone and what kind of processing is available. So the same thing is going to happen with our ears. We built our operating system called Cosmos to enable this to happen. We can now run apps that we can download from the cloud directly into your ears. So imagine what it would be like if you could download apps to your AirPods right now and turn them into a hearing aid. That would be something pretty important. So the co-processors, things like AI accelerators are still going to be needed. We still need a data pipe with different types of connectivity. We still need an audio codec. But the core of the system is around this new level of compute. What would this enable us to do? Well, some of our early adopter customers are already building products that are way beyond what you could do with a single chip Bluetooth system. So we have companies building premium audio for the home, so we can stream lossless data at very high data rates. We've got very low latency spatial audio streaming with multi-channel audio for gaming and watching movies. We're building what we call true wireless systems for a professional level. So we can now not just get good audio to the ear, but we can measure some of your biometric data and keep track of that. We can offload some of the AI processing. So if there are some really big, heavy lifting tasks that need to be done, we need to get that data off of the earbud into some other device and back again very, very quickly. And the final thing is what we call eardrop. So this allows us to put apps in your ears from your phone or your tablet. You can simply grab an app and immediately get a new experience. So the way the system works, and we have the demo just outside if you want to come and try this, is we can download apps to a tablet, and then as a user, you can pick which of those apps you want to use in your ears at any moment in time. Now to do that, you need an ear computer. Again, we have a prototype running now, and we'll have products launching next year that use ear computers. And the way the system uses that is inside each app is what we have a plugin, which is basically a software library that is built to run on top of Cosmos. And then the system takes those plugins that you've selected and puts them inside your ears. Now, it's normally at this point that most people are thinking, well, hang on a minute. If I've got all these apps on my phone, why don't I just do all the processing on my phone? I've got this great big computer. Well, the simple answer to that is look at what Apple did. Apple didn't do it this way. They had complete access to the iPhone, but instead they realized they had to build a new chip for the AirPod. They needed new connectivity. They needed new software. And that's why they can move ahead in the market. You cannot do these things on everybody's phone. The other way to look at this is all of the big headphone companies that are out there, companies like Bose, Shure, Sennheiser. All of these companies have had access to Android phones now for a very long time. And they've also realized they cannot deliver these features on the phone. It has to be done in the ear for things like latency, power consumption. If you imagine that you're watching a movie at home, but the only way your headphone works when you're watching this movie is you have to have your phone nearby so you can offload all the audio and get it back again. That's not a very good user experience. And that's why people know that computing has to be done inside the ear. So to kind of summarize what we've developed, the ear computer is basically two main components. It's an operating system that runs on a main processor. And by doing that, we can deliver apps directly into your ears. And these apps are going to do things that have been impossible with today's chips. We can do medical applications. We can monitor your health. We can analyze your speech. We can help you hear in noisy environments way beyond what you could do today. All of these things can now just be downloaded into your product. This means that these devices need to have more sensors. So we've got to get smart about how we pack them all into these tiny form factors. How do we run all these things at ultra low power so that the device lasts more than a few hours? These are all challenges that we're going to face as the product evolves. We need more connectivity. The future of wireless audio is not Bluetooth. We've already reached its limits, and now it's in the way. We have to transition to something else. And this means that we can now use the product for a longer period of time. So we don't just use it when we want to listen to some music to relax, but now I can use it for getting rid of noise when I'm outside or when I order a coffee inside Starbucks. I can use the device all day long, and it will gather all of this extra information in the background. So beyond hearables, we're already seeing a number of other opportunities. So some of the companies we work with, they make products in other areas. So they make things like fitness trackers, microphones, smart speakers. We're seeing people build medical devices because now they can download apps to these things while they're already deployed. So the extension to this into other IoT areas is pretty huge. So just to summarize, we're already providing our technology using tier 1 silicon that's already available in the market today. So we have 3 major players that we've partnered with so we can get products in the market next year. We have more than 100 companies building apps for your ears, and we expect that ecosystem to grow very, very fast. Now that we've taken the lid off the application development, suddenly we have access to a lot of new features and experiences. The first ear computer that anyone's ever had access to will be shown at CES, and we'll be launching with our silicon partners. And we'll be able to buy products off the shelf with an ear computer inside them next year. Thank you very much.